How's it going, everybody? This problem is asking you essentially what's the definition of a Bronsted-Lowry acid and what's the definition of a Bronsted-Lowry base. In terms of Bronsted-Lowry acid-base definition, this is all focused on proton donating and proton accepting. So donating and accepting an H plus ion. That's really all there is to it. At that point, you have to be able to draw Lewis structures and think about where are the possibilities for protons to be transferred. Well, a proton that can be transferred will be on something that is neutral or positively charged, and a proton that can be accepted will be accepted on something that is negatively charged or neutral. And in this case, you've got something that's negatively charged and positively charged in the reactants. So in that case, it's a lot more straightforward to figure out, okay, well, what's going to accept the proton and what's going to donate the proton? Well, a proton is a positive charge. So what's going to accept it is going to be the negatively charged oxygen. And so if I were to draw the conjugate acid of that base, so if it's going to accept the proton, it makes it the base, then I would draw the oxygen with a proton on it. And so one of the lone pairs will be used to make a bond. Then if that makes the acid, the ammonium ion. And so what that means is that the ammonium ion will lose a proton. And so the lone pairs of electrons in the ammonium that were attached to the hydrogen stay with the nitrogen. And so the conjugate base looks like that. And so the rest of the structure is just sort of a distractor. It's really just trying to get you to see that, well, where is the possible chemistry that can happen? Well, it's going to happen at a negatively charged location or a place that's very electronegative. That's what can accept a proton. Okay.